Welcome back. Over the past four videos, we've built a retrieval pipeline that's genuinely good. Smart chunking, query rewriting, re-ranking. Today we expose a fundamental limitation and fix it with Agentic RAG. Consider this question. Compare TechVault's PTO policy with the expense reimbursement timeline. Our pipeline runs, it retrieves PTO documents. PTO accrues at 20 days per year, but expense reimbursement, the pipeline already finished, it can't go back. What if it could? Before we come to solution, let's step back and look at what we've built. Smart chunking, query rewriting, cross-encoder re-ranking, the retrieval quality is excellent. The problem isn't quality, it's control. The pipeline runs once, returns results, done. Today we wrap it in something that can reason about what it found, decide if it needs more, and search again. That something is an agent. We will explore how to build it. Before we go to implementation, let's understand why we need agents. There are three types of questions that break single-step RAG. Multi-hop first. Compare PTO with expense reimbursement. Two different topics, two separate searches needed. Single-step RAG retrieves one or the other, never both. Aggregation. Which benefit has the longest weight? You need to check three policies, run three searches, then compare the results. And follow-ups. What about the exceptions? Exceptions to what? The agent needs to remember what it already found and reason about what's still missing. All three share one thing. The system needs to think between searches. That's the REACT pattern. REACT stands for reason plus act, and the whole thing is a loop. First, the agent thinks, what do I know? What am I still missing? Then it acts. It calls a tool. Search the database, run a calculation, or finish with an answer. The tool returns an observation, real data, not something the model invented. And then the agent thinks again, do I have enough or do I need one more search? The loop runs until the agent decides it's ready to answer. To make that concrete, here's what it looks like on our comparison question. The agent thinks, I need PTO information. First search. Gets 20 days per year. Thinks again. Got PTO. Now I need expense reimbursement. Second search. Within 30 days. Third thought. I have both. I can compare now. Done. Two searches, three reasoning steps, one complete answer. Before we look at the loop itself, let's understand what the agent can actually call. The search function wraps everything we've built in this series. Embed the query, retrieve from ChromaDB, that's video 2, re-rank with the cross-encoder, video 4, return the top three chunks as a string. Register this as a tool with the agent, and when the LLM outputs search query, this function runs. Now let's look at the code behind it. We initialize the agent with a tool registry and a hard iteration cap, a safety net so it never runs forever. The system prompt is a function, not a static string. It builds the LLM's instructions on the fly. Tool names pulled from their doc strings and the exact thought action format the agent must follow. Before the loop, we call it once to build the initial messages array, system prompt plus the user's question. And now we enter the loop. Each iteration is one round of reasoning and action. We send the full message history to the LLM and wait. Its reply gets appended as an assistant message. We parse the reply. If the action is finish, we return the answer. The agent has enough information. Otherwise, we run the tool, get the observation, and append it to messages. The loop continues, reasoning, acting, observing, until the agent decides it's done. Alright, let's dry run through the code. We'll start simple. TechVault's PTO accrual rate. The agent thinks, I need to find the PTO policy. One search. Gets the policy. Thinks again, I have the answer. Done. On easy questions, the agent doesn't over-search. Now let's give it something harder. Now the comparison question. Two things to compare. It knows it needs to search both. PTO first. Gets the details. Remembers what it found, identifies the gap, expense reimbursement. Second search, gets the timeline. Now it has both pieces, synthesizes a comparison. Two targeted searches, three reasoning steps. Each search was informed by what the agent already knew. That's the power of interleaving thinking with searching. Now let's push it further. Three benefits, three searches. Health insurance first, 60 days. PTO next, immediate. Now 401k, 90 days to enroll, 1 year for the match. The agent builds a running comparison as it goes. Longest wait, the 401k match at 1 year. No single search could have answered this. Three decomposed subqueries, then synthesis. Now that you've seen what agents can do, let's talk about what can go wrong. Infinite loops. The agent searches for something that doesn't exist and retries endlessly. The max iterations limit catches this. Oversearching. Six searches for a question that needs one. A per tool call limit helps. Hallucinated tools. The agent invents a function that doesn't exist. Validate the action name before executing it. These aren't hypothetical. Here are the two code guardrails that handle them. Validate the tool name. If it doesn't exist, tell the agent what is available so it can self correct. And track search calls. After 5, force the agent to finish with what it has. Not a crash, a graceful degradation. An unconstrained agent loop is a runaway API cost. Both guardrails are non negotiable in production. Before we wrap up, it's worth knowing that React isn't the only agent pattern. We built React, think, act, observe. General purpose and easy to debug. Plan and execute creates a full plan upfront, then runs each step. Useful when those steps can be parallelized. Self-RAG is a fine-tuned model that decides when retrieval is even needed. No wasted searches on easy questions. Corrective RAG grades every retrieved document and falls back to web search when quality is low. Start with React. These alternatives solve problems you'll encounter at scale. So, when does adding an agent actually make sense? If single step RAG handles most of your queries, stay with it. Agents add latency, cost, and moving parts. If you're seeing comparison questions, multi hop reasoning, or synthesis across documents, that's where agents earn their cost. In production, route simple queries to single step, complex ones to agents. You don't need to pay the agent cost for everything. We've now built the complete RAG pipeline, from raw documents to an agent that reasons and searches on its own. But here's an honest question worth sitting with. Is RAG always the right answer? What about data with rich relationships? What about static knowledge that doesn't change? What about domains where exact keyword matching matters more than semantic similarity? Next video, the alternatives. When to use RAG, when not to, and what to reach for instead. Thanks for watching. Subscribe so you don't miss the final video. That's where we honestly evaluate when RAG is and isn't the right choice. See you in part 6.